All right, and welcome here to week 3. And this week our topic is going to be actually cameras and the functions of cameras. So, what you should have gotten a little bit of last week in the history setting was the word photography. It is actually broken down from the Greek words of phos, which means light, and graphos, which means to write. So photography is a mixture of phos and graphos to mean, writing with light. And essentially, when we look at the old cameras where you had film, it was the light hitting that film, creating something on the emulsion, so that when you developed the emulsion, lights and darks were left behind, and that, was a representation of that image based on the light. Now, today we've added digital media, so it's now just a sensor that has a sensitivity to the light such that we end up having, the light striking that sensor, and when it strikes that sensor, it then creates a digital image for us. It writes the ones and the zeros. So when we look at, a camera, essentially, what you have here is the different components of the lens, which usually are a couple of different pieces of glass for the focusing. So as you adjust the lens, and we'll talk about lenses a little bit later, but as you adjust the lens, those glasses move back and forth, and that adjusts stuff like magnification for zoom lenses, and also does our focus. A lot of times you can equate this to if you have a pair of glasses on your face. If you pull your glasses forward, things get blurry. You push them too close to your eyes, they get kind of weird. So you set it in the middle, and everything is right about what it's supposed to be. So light comes in through all here, and there's a couple other little pieces that are, going to be talked about later. But eventually, the light hits the sensor, which is called a CMOS chip, and that light then, turns into ones and zeros, and this then creates our image. Now, the lenses have a couple different parts. One of the first parts of the camera that we want to talk about is something called the shutter. And the shutter is very similar to the human eye. So think of the shutter as being, your eyes open or closed. When your eyes closed, there's no light getting in, so you can't see anything. When you open your eyes, now the shutter's open and you can see stuff. So while we as human beings want to pretty much always be seeing stuff, so our shutter is always open, on a camera, typically the shutter is always closed because we don't want the light going in and touching those sensors and affecting them. Now, in human beings, our eyes are always open, so, we're always seeing. The camera, where the shutter's always closed, where it can't see, when we open the shutter, that is when the camera gets to view the world around it. And our shutters operate at different speeds. The time of how long the shutter is open will determine how much light we allow into the camera. So a shutter could go, from a really slow speed, like 1 second, where the shutter is open 1 second, to something really super fast, like 1/2000th of a second. The shutter is open like that, and it's gone. The longer the shutter is open, the more light coming into the camera. But the longer the shutter is open, anything that's moving, that movement is going to be caught by the camera. Now keep in mind, we're taking still pictures, so any movement is not going to be like a video, it's going to be a blur. Sometimes, we will want to have the camera open for a long time, the shutter open for a long time, so we actually have something called a bulb setting, where as long as you're holding down the button, the lens is open, or the shutter is open. So putting this in practical, what we have here is, say, the pinwheel spinning. When we have a super fast shutter spinning, like 1/1000th of a second, we actually freeze the pinwheel. When we start having a slower shutter speed setting, like 1/50th of a second, 1/20th of a second, notice we have this little bit of blur. When we leave the shutter open for closer to a second, it's nothing but blur. So, pinwheel spinning all at the same speed, lighting conditions all the same. Essentially, we've just changed the shutter speed, and this dictates whether we get something that's locked in solid, a little bit of blur, or a whole lot of blur. Something else that's inside of our camera, something called an aperture. Apertures are measured in f-stops. The aperture is like the pupil to your eye. So, that black part of your eye where there's no color, when you're on a bright sunny day, that gets a little tiny pinpoint. And when you're outside and it's really dark, it gets really big and you don't see any color in your eye. Everything goes black. So the camera's kind of the same way, where you've got this disc inside of the back of the lenses by the shutter that can open and close depending on how much light we want to come through. So you can have a really small opening, like say something like f16 or f22. F32 is the smallest setting, all the way up to something like an f2, which is the largest setting, which means the whole camera lens is able to have light pass through it. So we've got two different things now affecting how much light's coming into our camera. You've got both the shutter speed and our aperture. So you might want to say at a scene, you want a slow shutter, or a fast shutter speed. So you want to have that shutter go really quick because we want to take a picture of something and we want it to look like it's standing still. But because it's rather dark out, what we need to do is we need to get more light into the camera, so we have a higher, more open aperture, or a lower aperture setting. So this way more light is coming into the camera because we have a bigger hole for the light to come through, but yet it's balanced out because the shutter is so fast. One of our problems here with depth of field that we always have to be, or one of our problems with our apertures that we have to always be aware of, is what's called depth of field. Depth of field is how far away we can focus on something. So depending on your aperture will depend on what your focal field is. Now, there's also some other things like your focal length of the lens. There's a few other little nuances that come into play here. But for the most part, here we've got like a chessboard and you can see the rook, the bishop, all the things down in the other rook. Versus down here, we've got the rook. The bishop you can kind of see them, but then by the time we do the king, queen, bishop, everything's all blurry. Even look at the pawns. You can see the pawns all the way over to the rook on the other side of the board. All these pawns are just lost in a blurry mess. So from a crime scene standpoint, we want stuff to be in focus. So we need to be cognizant of what our aperture is so that we don't lose our depth of field. All right, so we've got these shutter speeds. We've got depth of field. These are two things that affect our ability to get light in the picture and get a good photo. There's one other thing that affects our light. It's something called ISO. Back in the day of 35mm film, we were concerned with ISO because it was a function of how they made the film. How much chemical, how much silver nitrate was on the film dictated how sensitive it was to light. You put more on, you had more light sensitivity. You didn't have as much light sensitivity. Problem is the more chemical you had on the film, you would start to lose clarity for your picture. The picture couldn't stay as crisp and clean. With digital cameras, we have a similar kind of thing. It's basically how much power we're putting to that chip affects how sensitive it is to light. But the more we start adding to that chip, the more we make that chip sensitive to light, we end up losing clarity in our image. So here you can see how, this is a small picture, so we're not really losing any clarity. So you can see where ISO is a big help for us. So at ISO 200, this picture's kind of dark. And as we go up to more light sensitive, like ISO 800 or 1600, now our picture's got much lighter. And the ISO settings, the lower the number, the less sensitive it is to light. The higher the number, the more sensitive it is to light. Kind of showing this as a trade-off. Here we have our ISO 100 on a nighttime picture, and it's okay. It's a little dark, so we make our camera more sensitive to light. Well, now it's a lot brighter picture, but it's kind of blurry-ish. We're losing the detail of the windows, and let's just keep jacking it up. 3200, it's just all pixelated, and by 6400, it's just it's gotten darker a little bit too. Might have changed a shutter speed or an aperture setting. But at 6400, this ISO, everything, it's all kinds of speckles and dots in the sky, which you don't have that here. You're starting to get that here, and here it's really getting bad, and here it's just, it doesn't look like a nice clean sky. So really here what we're talking about is creating a balance where you've got your triangle, you've got your aperture, you've got your shutter speed, you got your ISO, and what happens is we're always trying to create balance where we decide, do we can we allow a little bit of motion blur or not? If you're taking pictures of stuff like fingerprints and, blood stains, it's not moving. So we don't have to worry about motion blur. We can have shutter speeds pretty, long. The problem though is if I've got a long shutter speed and I'm holding my camera, any shake or vibration in me is going to cause motion blur on the camera standpoint. So you either get motion blur because the subject of the picture is moving, or you get the motion blur because you holding the camera, taking the picture, are vibrating and moving. And we typically say like a shutter speed of 1/50th to 1/60th of a second. That's about as slow as you can go and hold a camera still as an average human being. So then we've got our aperture, just like the pupil. It's that thing that opens and closes, determines how much light is or isn't coming in through the opening of the lens, but that has the trade-off of our depth of field. Can we focus on stuff both close and far? Again, sometimes at our crime scenes, you're taking a picture of just like a fingerprint. So we don't need a deep depth of field because we have an object on a surface. Then we have our ISO. The ISO, when you have a lower ISO number, the camera's less sensitive to light, which means you need to have a longer shutter speed and, a smaller aperture number, which creates a bigger hole. But if we want to turn the ISO up to, counterbalance any motion blur, suddenly then we start adding in potential noise. And if you're taking, say, a picture of, say, a fingerprint or something, we don't want any noise. We want a nice, good, crisp picture. All right, so this is some basic camera operations. This is going to be a multi-part recording this week, so this will be the end of part 1. I will see you for part 2 in just a second.